Here's the punctuated version of your text. Imagine a glorious item, not at all like anything we've at any point owned, hopping the tremendous scope of space at multiple times the speed of the regular comet in our planetary system. This isn't a manufacture of science fiction, but a peculiar visitor entering our planetary system in 2017. This remarkable article is the first interstellar object ever seen in our nearby planetary system, named Oumuamua, in Hawaiian, meaning a messenger from afar. At first, it bewildered stargazers and generated theories ranging from it being simply a space rock to perhaps an alien spacecraft cruising through our galactic neighborhood. Oumuamua was 15 million miles from Earth, about 60 times the distance from Earth to the Moon. What astounded researchers was its speed. As it rounded the sun, its rate increased, going against the laws of celestial mechanics. Might it be influenced by some unexplored type of cosmic radiation? Or is it a comet releasing gases in a way we've never seen before in a universe governed by rules and conditions? Oumuamua is a perplexing case, a massive puzzler, resembling a stone around 650 feet long. On October 19, 2017, a telescope in Hawaii detected a faint streak. This was no ordinary celestial body. It was Oumuamua, the first known interstellar object to visit our nearby planetary system. Unlike asteroids and comets formed under the gravity of our sun, Oumuamua was a drifter from deep interstellar space. Its trajectory indicated that it was not bound by the sun's gravity, making it a transient visitor to our system. What sets Oumuamua apart is not only its origin but also its unique characteristics. Its elongated, cigar-like shape, its rapid rotation. They defy the norms of typical objects in the nearby planetary system. The academic community is buzzing with theories and discussions about Oumuamua's nature. Is it a comet without a tail, as seen with an unusual rotation, or something entirely different? These questions have sparked rigorous scientific inquiry, leading to a range of theories, from it being a fragment of a larger celestial body to even more speculative ideas, such as it being an alien probe. The discovery of Oumuamua is a milestone in cosmology, akin to when people first looked through a telescope and realized that Earth is not the center of the universe. It offers insight into the composition of the nearby planetary system and tells us that our solar system is just a small part of a vast, unexplored frontier. As Oumuamua moves farther away, becoming a faint spot in the vast expanse, the desire to study it grows. Hopefully, with future advanced telescopes, we will gather more information about these interstellar messengers, offering new clues about the structure and history of the universe. Further examination of Oumuamua reveals intriguing details. Initially labeled a comet, it lacked the typical comet-like features, such as a bright coma or tail. This led to its reclassification as an asteroid. However, it is not just any asteroid. It is an elongated, cigar-shaped object unlike any asteroid we've seen before. Its unique shape has led to various speculations, including the possibility that it is an alien spacecraft. Scientific papers describe Oumuamua's physical characteristics in more detail. They note that the object is tumbling rather than spinning, which is unusual for both asteroids and comets. This tumbling motion could be the result of a collision with another celestial body, but this is purely speculative at this point. Oumuamua's trajectory presents another enigma. It entered our solar system at an unusually high speed and continued on an exaggerated path, implying it will never return. Most objects captured by a star's gravity go into an orbit, but not Oumuamua. According to researchers, its trajectory was influenced by non-gravitational forces, potentially due to the release of materials from rapid sublimation. However, no such gas outflows were observed, which further adds to the mystery. The absence of a noticeable coma in the object's path has led to various theories. Each detail uncovered about Oumuamua adds to the mystery, prompting further study and speculation within the scientific community. Some scientists suggest it could be part of a larger object that disintegrated, while others believe it might represent a new class of object rather than a comet or asteroid. Some even entertain the possibility that Oumuamua is a solar sail driven by radiation pressure. The notion that the object's speed could make it a messenger from another star system, perhaps propelled by a planetary system orbiting a young star, is intriguing. This could make Oumuamua one of the first observed interstellar objects, a remnant from another part of the galaxy. The story of Oumuamua is a cosmic detective story where each clue only deepens the mystery. Its elongated shape is unlike anything we've seen in the solar system. Could this unique shape ever offer advantages for interstellar travel, such as reducing drag or enhancing stability? Or is it the result of some destructive event we cannot yet understand? This trajectory adds another layer of mystery. The absence of a visible coma and tail rules out the possibility that outgassing affected its path. So, what non-gravitational forces are at play? Might it be influenced by dark matter or some other unknown cosmic phenomenon? The hypotheses surrounding Oumuamua range from the plausible to the extraordinary. Could Oumuamua be a harbinger, a messenger from another star system? The possibility that it is a solar sail is particularly captivating, and if proven, it would revolutionize our understanding of space travel, opening the door to the possibility of radiation-propelled voyages between stars. In studying celestial objects like Oumuamua, astronomers rely on various tools. The investigation into Oumuamua's nature was led by a team of researchers, including Jennifer Bergner, a physicist at the University of California, Berkeley, and her partner Daryl Seligman, an astronomer at Cornell University. Their work, published in the journal Nature, is considered the most convincing model for Oumuamua's origin. According to Marko Melnik, an astronomer at the European Space Agency, the team's observations were supported by NASA's Hubble and Spitzer telescopes, which found that Oumuamua had a strangely elongated, cigar-like shape and accelerated somewhat as it left the solar system. This acceleration is often seen in comets when they are repelled by the material they emit, but Oumuamua showed no such emission or apparent significant outgassing of dust and gas that we would expect from a comet. The team used modeling to suggest that Oumuamua could have started as a typical water comet orbiting a nearby star before being ejected from the system. High-energy cosmic rays might have converted up to 30% of the comet's water ice into hydrogen, which could have been trapped in Oumuamua's ice as it traveled through interstellar space. As it approached the Sun, the trapped hydrogen should have been released, providing the acceleration observed by Seligman. The team's hypothesis accounts for each unusual aspect of Oumuamua. It suggests that Oumuamua was indeed a comet but an unusual one. The absence of a visible coma or tail can be explained by the fact that atomic hydrogen is much less massive than the materials emitted by regular comets and thus doesn't drag along much dust. While Bergner and Seligman's theory is compelling, it is important to note that not everyone in the scientific community is convinced. Karen Meech, an astronomer at the University of Hawaii at Manoa, still believes that the traditional comet model might apply. She suggests that Oumuamua could simply have a small amount of dust, which would also explain the lack of a visible coma or tail. Another hypothesis that Oumuamua could be an alien probe has captured the public's imagination. Its elongated, cigar-like shape and unusual trajectory have led to speculation that it might be an artificial object. This theory gained some traction when Avi Loeb, an astrophysicist at Harvard, suggested that Oumuamua could be a thin, flat, nearly rectangular piece of material that could be a probe sent by an advanced civilization. This hypothesis was widely reported in the media, fueling speculation. However, while the alien probe theory made headlines, it has not stood up to scientific scrutiny. For one, if Oumuamua were a probe, it would likely have emitted some form of radiation or signals that would have been detected. Furthermore, its tumbling motion does not align with what one would expect from a probe designed for continuous movement or data collection. Additionally, the object's trajectory can be explained by natural anomalies, as discussed earlier. The theory proposed by Bergner and Seligman, suggesting that Oumuamua is a hydrogen-rich comet, accounts for its unusual characteristics without requiring extraterrestrial intervention. The idea that Oumuamua might be an alien probe reflects our collective fascination with the unknown and the possibility of intelligent life beyond Earth. However, it also serves as a reminder of the importance of thorough scientific investigation. Speculative theories, while intriguing, can divert attention from more plausible explanations. Despite its enigmatic features, the most likely explanation for Oumuamua is that it is a rare type of comet or asteroid. Its long journey through interstellar space likely altered its composition, forming a surface that retained most of the frozen gas inside. This hypothesis accounts for the object's unusual characteristics and is supported by observations from NASA's Spitzer Space Telescope. The discovery of Oumuamua has significant implications for our understanding of interstellar objects. It suggests that trillions of such objects might pass through our solar system, and we have only just begun to detect them. The Large Synoptic Survey Telescope, LSST, in Chile is set to receive its first engineering camera in December 2023, with full survey operations scheduled to begin in October 2024. Once operational, LSST will potentially be able to detect more objects like Oumuamua. It is projected that LSST data will be made publicly available in 2 years, opening new avenues for studying these mysterious interstellar visitors. Beyond telescopes, advancements in propulsion technology and data analysis might allow us to track and study these objects more closely. Imagine a future where we could send a probe to rendezvous with an interstellar object, collect samples, and send back data in real time. The development of the European Comet Interceptor mission, recently approved, represents a significant leap in our ability to study interstellar objects like Oumuamua. Unlike previous missions designed to study objects within our solar system, the Comet Interceptor is specifically designed to gather data on objects from outside it. The mission, led by ESA with support from the Japanese space agency JAXA, aims to study a comet that has spent little time in the inner solar system and might be visiting for the first time. The mission will build on the successes of the Rosetta and JATO missions, which studied short-period comets. The spacecraft will consist of a main unit and 2 probes designed to observe the comet from different angles, creating a 3-dimensional profile of its surface. The mission is expected to launch in 2029 and will travel to space with ESA's aerial mission. Once in space, the Comet Interceptor will wait at the Lagrange point L2, an area 1.5 million kilometers behind Earth from the Sun, awaiting the next interstellar object to pass through our solar system. Once such an object is detected, the spacecraft will alter its trajectory to perform a close flyby, capturing high-resolution images and gathering data on its composition, and potentially even beginning its investigation. The discovery of Oumuamua has opened a new chapter in astronomy. How common are such hydrogen-rich objects in the universe? Are there other interstellar objects with different compositions and behaviors? And most importantly, how can we better study these objects in the future? Oumuamua has served as a harbinger of future discoveries, preparing us for new interstellar visitors that may be just as perplexing, if not more so.